Hi, and welcome to Physical Computing with Microbit. In this video, we're going to learn about physical computing and give an overview of the different topics we'll learn throughout this course. Let's jump in. Physical computing is creating or using devices that interact with the world around them. Think of a robot. The robot first senses their environment, thinks about the information gathered, and acts based on that information. A self-driving car is a great example of a device using these physical computing steps. Though this is a complicated system with many inputs and complex programs, the main parts of a self-driving car work the same as any system we'll build in this course. The car uses multiple sensors to detect its surroundings, analyzes what this data means, and then acts accordingly. In this course, we're going to be using microbit devices to create programs that allow our device to interact with the world around it. Even though your microbit looks simple, it has sensors that can help it note changes in the environment and react based on the program you've written. It can sense acceleration, light, temperature, and direction using built-in sensors. Here's an example. We can use our temperature sensor to find the temperature of the room. It finds that the temperature is 19 degrees Celsius. It then thinks by applying this value to the program that has been written. It sees that if the temperature is less than 20, a light or LED should turn on. So it acts on this and lights the LED. In the last example, we used an if-else statement in our code. You've probably already learned a few of these programming concepts, such as variables, loops, and functions, and now we'll be able to put all of those concepts together to create physical machines. These concepts will form the foundation for how you can communicate with your device and program how it should sense, what it should think, and how it should act. We're going to cover a lot of content in this course and build some awesome projects. Let's take a deeper look at all the content packed into these three modules. In the first module, we'll go through the basics of our microbit, such as how to light up and change the brightness of LEDs, and learn how we can use variables to make our programs more versatile. We'll build our first circuits to control external LEDs with our microbit and explore how we can use pseudocode to structure our programs from the start and comments to make our programs readable to us and others. In the program control module, we'll learn how to apply control structures, such as if-else statements and loops, to create programs that will react to the outside world. We'll build programs that use the built-in sensors that detect temperature, light, and acceleration, as well as external sensors, such as an ultrasonic rangefinder, which detects the distance from your device to nearby objects. In the final module, you'll have a chance to explore all the capabilities of your microbit on your own. You'll research, explore, and teach your peers about new sensors, follow directions to build an advanced device, and have a chance to create your very own microbit machine. Now that we know all about the awesome things we're going to learn to do in this course, let's get into how we're actually going to do it. It all starts with the microbit code editor. Note, you can switch between blocks and Python in MakeCode by clicking the toggle at the top of the editor. Let's take a look at the features we can find there. To get to the microbit code editor, we navigate to makecode.microbit.org. If you've taken courses on CodeHS previously, you may notice this is a bit different. In this course, you'll be developing and testing programs on the microbit editor, and once you've successfully completed an exercise, you'll copy and paste your code into the CodeHS editor for your teacher to grade. Let's head there now to check it out. To create a new project, I'm going to click on this big purple button here, and I will be prompted to name my file. I'll just name this one Test for now. Once in the editor, on the left side of the screen, you'll see a microbit simulator. This is a helpful tool that can test your code before running it on your actual device. The main editor page will load blocks as the default way to develop programs. In our course, we'll be writing all our programs in Python text, but check with your teacher to see how they prefer you to develop programs. To switch to Python, we can navigate to the JavaScript button here, then select the arrow next to it to change the base code to Python. A forever function will automatically be added to our code, but you can easily remove it if you don't need it in your current program. You write your code in here, and all the commands you have typed will run and the output will be shown on the simulator. If you want to download your code onto your physical microbit, plug your microbit device into the USB and click the three dots next to the download button here. You're given two options. If you select Download as a file will be created that you will need to drag and drop onto the device on your computer to see the output run on the device. If you instead select Connect Device, You will be able to select your device, and from then on, your programs will be downloaded onto the device with one click of the download button. You will find more resources on how to download your programs in a following item. Now it's your turn to explore some microbit programs.